Okay, so today is just a continuation of what we did yesterday. It's still the same section of the chapter, 6.4. And it's up to you, but this is just a picture that's from page 440 in your book, so it's up to you if you need to copy it into your notes or not. I'll leave that up to you. Your notes are your notes. But yeah, we're going to be talking about the inverse graphs a little bit. So like I told you yesterday, the inverse graph is a reflection across the line x equals y. And so in the pictures here, what they've got is the original, this is the original function in blue on each of them, and then they have the inverse in red. So sometimes your inverse is a function and sometimes your inverse is not. So in the first example, the inverse is not a function, but in the second example it is. So it just depends on what your original graph was. There's no like hard and fast rule that it's always going to be a function or it's always not going to be a function. It just depends on the original graph. So let's take a look at example 3. We're going to find the inverse of f of x equals x squared. And in this case, they're actually limiting the domain, saying that x is greater than or equal to 0. And then we're going to graph both the function and its inverse. So first looking at finding the inverse, I switch my x and y. So now x is equal to y squared. So I have to take the square root of both sides. And so normally y would be plus or minus the square root of x. But again, they've limited the domain right here. So my inverse is actually just going to be the positive square root of x. So I'll write it that way. Okay, so that's my inverse. So now I'm going to make a table for each of them and graph them on the same graph. So first I'll do the original function. Make a table here. Okay, so I'm looking right now, I'm looking at f of x equals x squared. So if I plug in a 0 for x, what's 0 squared? 0. If I plug in a 1 for x, what's 1 squared? 1. If I plug in a 2 for x, what's 2 squared? 4. And 3 squared? 9. Okay. So if I plotted that, I'd have 0, 0, 1, 1, 2, 4, and 3, 9. So my graph would be half of a parabola, again, because they've only said the domain was x greater than or equal to 0. All right, now I'm going to do the inverse. So if I plug in a 0, what's the square root of 0? 0. And if I do 1, what's the square root of 1? 1. And I just want to pick perfect squares, so if I put in a 4, what's the square root of 4? 2. And 9? 3. And so notice that my input and my output are just reversed on my tables because they're inverses of each other, okay? All right, so if I plot those points, and there. So now when I draw this one, it goes like that. And again, it's just the reflection over the line y equals x. Can you kind of see how it's a mirror image if you think of that line being the mirror in the middle? Yeah, okay. All right, so remember the vertical line test. We talked about that's what tells us whether or not it's a function. We take a vertical line and see if it ever crosses it more than one place, right? Okay, so when we take the inverse, what happens with the graph is because it's a reflection across x equals y, it actually flips it over. So I'll just kind of show you. What happens is it flips it over and turns it sideways. So let me flip it left to right, and then if I turn it sideways, this is what the inverse graph is going to look like. So if I take this line, well, basically now if I take my vertical line to this one, oh, my line's hidden behind there. That didn't work. Let's move that back. Bring this to the front. Corner. Bring to the front. Okay. Now if I take my vertical line, is the inverse going to be a function? No, it's not. So rather than going to the trouble to graph the inverse, I can actually take a look at the original graph and do a horizontal line test. So if I graph the original graph and do a horizontal line, then I can tell whether or not the inverse is a function. So in other words, if I hadn't gone to the trouble to flip it and turn it sideways, I could have actually just taken a horizontal line over here and I would have seen that the inverse would not be a function. Okay? And again, this is in your book. It's on the same page, 440 down at the bottom. All right, so we're going to consider the function f of x is equal to 2x cubed plus 1, and we're going to determine whether the inverse is a function. And I left my line there from the last period. There we go. All right, and then we're going to find the inverse. So rather than graph both of them, I'm actually just going to graph the original one and figure out whether or not it would be a function, and then I will find the inverse. So first thing I want to do is make myself a table. And again, I'm just graphing the original function right here. So if I'm going to plug in -2, -1, 0, 1, and 2. So a -2 cubed, what's -2 times -2 times -2? -8 times 2 is -16, and then when we add the 1, we get -15. All right, then I plug in a -1. -1 to the third power is still -1 times 2. I have -2, so -2 plus 1, we get -1. All right, if I have 0 cubed, that's just 0. So 0 plus 1 is 1. And then when I put in a 1, I get 1. 2 plus 1 is 3. If I put in a +2, I get 8. So 16 plus 1 is 17. All right, so now when I graph it, the -2 and the +2 aren't going to fit on there, but they give me an idea of where the graph is coming from, so it still helps me with the graphing. So let's see here. -2 or -1, -1, 0, 1, and 1, 3. So I know that it's way down here somewhere to begin with, and then it comes up through these points, and then it's got to go up fairly straight too if it's going to get to negative or get to +17 there. So to decide whether or not its inverse is a function, I just take a horizontal line and test it. So is there anywhere that a horizontal line is going to touch it more than once? No. So that means that the inverse is a function. And then it's just a matter of finding the inverse. So to find the inverse, I switch my x and y. So now I have x is equal to 2y cubed plus 1. So to get the y alone, I subtract 1 from both sides, and I get x minus 1 equals 2y cubed. And then we divide by 2. So now I have y cubed is equal to x minus 1 over 2, and then I just have to take the cube root of both sides. And so the inverse is the cube root of x minus 1 all over 2. Okay, so when you're doing your homework, just follow the instructions. If it says to graph both of them, graph both of them. But if it says determine whether the inverse is a function, then you really only have to graph the original function, okay? So it just depends on what the instructions say, so read the instructions for a change. Any questions? No? We're good? All right, that's it for today.